So let's find the area bound between, and we're going to put three curves in here. Y is equal to x squared minus 1, y is equal to x minus 1 squared, and y is equal to x plus 1 squared. And graphing these again will kind of give us a handle on what we're doing here. So draw my x-axis, y-axis. This is x, this is y. And so the first one, so we'll do y is equal to x squared minus 1. That's a quadratic, shifted down 1. And it has roots at 1 and at minus 1. So it's a quadratic or a parabola. Has to look something like this. So that's y is equal to x squared minus 1. Now for the second curve, x minus 1 squared, this is the parent function is x squared, but we're shifting to the right 1. So it is just a parabola whose vertex is here and looks like this going that way and like that going that way. So that's y is equal to quantity x minus 1 squared. And then for the last curve, we've got y is equal to x plus 1. And we should note, just for completion here, that where does it cross the y-axis? Well, when x is 0, then y is 1. So that value is 1 right there, and we'll need that in a second. So this graph right here, y equals x plus 1 quantity squared, again, same like this. It just, the x squared term shifted to the left now, and so it's going to look something like this. And it will cross at the same place. So this is y is equal to x plus 1 squared. And so the region we're looking for, we want to know what is the area in here. What is that area? That's what's bound between these three curves. And we can already see that we're going to have a common point here. X is going to be running from -1 to 1. And the bottom graph is always the blue curve, right? Y equals x squared minus 1. But now I've got two upper bounds. And so what I need to do here, because this, I've got an orange curve half the time, then the green curve the other half, I'm going to split it up into two different regions. I'll call this A and B. And so the area, total area, will be A plus B. And in A, right, I've got the upper bound is x plus 1 quantity squared, lower bound is x squared minus 1. For B, the upper bound is x minus 1 quantity squared, lower bound is x squared minus 1. And so putting this all together, I can calculate my area. So the area will be A plus B. A is the integral, so x ranges from -1 to 0. The upper graph is x plus 1 quantity squared minus x squared minus 1 plus the integral. Now I'm going to go from 0 to 1, the integral 0 to 1, and it's the graph x minus 1 quantity squared minus x squared minus 1 dx. Those are my two integrals I need to evaluate. So this is equal to the integral of -1 to 0, x squared plus 2x plus 1 minus x squared plus 1, and then the integral between 0 and 1 of x squared minus 2x plus 1 minus x squared plus 1. Simplifying a little bit, right? My x squareds, in both cases, they will cancel out. And then in this case, I've got the integral from -1 to 0, 2x plus 2. And here I've got the integral 0 to 1, and I've got a minus 2x plus 2. And I can't combine these because they're two different bounds of integration, and so I just have to run them separately. But that's fine. The antiderivative of 2x is x squared. So I got x squared plus 2x integrated between -1, or evaluated, sorry, between -1 and 0, plus negative x squared plus 2x evaluated between 0 and 1. So here the upper bound is 0, so that's all 0. I'll write it out. 0 squared plus 2 times 0, that's 0, minus -1 squared plus 2 times -1. That's that region. Plus -1 squared plus 2 times 1 minus -0 squared plus 2 times 0. So 0, 0. This is a 1, and this is a -2. So this is equal to -1 plus, and then so this is 1 squared. That's a -1 plus 2, so just plus 1, because these are all 0, and so ends up being 2. So the area of this region, the area of this purple region, is 2. That's how big that area is. So this last problem we're going to look at kind of puts things a little bit differently. Let's find the number C so that the region bound between y equals c and y is equal to x squared is equal to 36. So what's given here is we're told what the area needs to be. The area needs to be 36. The variable, the question is, what should C be? What is C so that this is true? Now let's kind of graph what things are looking like here. So if I've got the graph of y equals x squared, that's a parabola. So y equals x squared looks something like this. Of course, it comes down and touches there, bad graph. So that's y equals x squared. And y equals c. Well, c can be any number, but I want it so that it bounds some region. If c is negative, right, if c were down here, these guys would never intersect and there'd be no region bound between them. So that is not a candidate for C. In fact, C is going to have to be positive in order to have some intercept. So y equals C. And so if y equals C, then we know that x is going to be the square root of C over here, and x is going to be negative square root of C. those will be my bounds of integration if I want to know what that area is. And I'm told that that area has to be 36, right? This region has to have an area of 36. And now I can set up my integral. 36 has to be equal to the area between these two curves. So in other words, 36 has to be equal to the integral between negative root c and positive root c. And it's going to be, what's my upper function? It's c, y equals c, minus the lower function, which is x squared. So 36 has to be equal to this, and now I can use the fundamental theorem, and this is equal to c times x minus 1/3 x cubed, evaluated between negative root c and positive root c. Right? So that's my integral. So I can set up this equation. So this says that 36 has to be equal to c times root c minus 1/3 c to the 3/2 minus c times negative root c minus 1/3 times negative c to the 3/2 again. So 36 is equal to c, well, let's just rewrite this. This is, right, this is c times c to the 1/2, which is equal to c to the 3/2. So I can simplify my algebra here. So this is c to the 1/2, or c to the 3/2 minus 1/3 c to the 3/2. So that's just 2/3 c to the 3/2 minus, and again, this is going to be a negative c to the 3/2. That's what that is. And then a minus and a minus. This becomes positive 1/3 c to the 3/2. So this is going to be a negative 2/3, but I've got a negative out here. So it becomes a positive 2/3. This all becomes 4/3 c to the 3/2. And so then solving for c, so this is what, 3/4 times 36 is equal to c to the 3/2, or where is this? 27 is equal to c to the 3/2. And so c is going to be equal to 27 to the 2/3, which is, so cube root of 27 is 3, squared is 9. So that's our c. So if c is equal to 9, the area will be 36. Okay, so that's kind of captures all the ideas in area between two curves. It just takes on the ideas of general area using the fundamental theorem. The key takeaway should be you've always got to have the larger function first and you subtract the smaller function. If you do that backwards, you'll end up with a negative area typically. So you can quickly kind of find out that you made a mistake, but nonetheless, it's apparent that the larger function comes first and you subtract the smaller function. All right, so that wraps up section 4.5. Happy mathing to you and best of luck.